All right, so we're going to prove that if r does not equal 1, then for every positive integer n, a plus a times r plus a times r squared plus dot 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 plus a times r to the n is equal to a times r to the n plus 1 minus 1 over r minus 1. So we're basically proving the geometric series formula using the principle of mathematical induction. Okay, so a proof by PMI. The base step, we're going to consider P of 1. So notice how it goes from a plus a times r plus a times r squared, and it's a times r to the n. So really, when we're considering the first case, the first positive integer, right, aka 1, it's actually the sum of these two right here, right? So we have to show that a plus a times r is equal to this formula. So let's go ahead and do a times r to the 1 plus 1 minus 1 over r minus 1, which is the same thing as a times r squared minus 1 over r minus 1. And you can see that this is a difference of squares. So it's a times r plus 1, r minus 1 over r minus 1. We have a factor of r minus 1 in the numerator and the denominator. So this is a times r plus 1, which is, of course, a plus ar. So it checks out for the first case. Let's go ahead and look at the second, right? So consider P of 2. So that's the sum of the first three terms in the geometric series, right? Okay. So that's a plus a times r plus a times r squared. And the formula is going to be a times r to the 2 plus 1 minus 1 over r minus 1. This is going to be a times r cubed minus 1 over r minus 1. So this is a difference of cubes, right? So the difference of cubes is going to be a times r minus 1 times r squared plus r plus 1. All right, so we have a factor of r minus 1 in the numerator and the denominator. So that's going to give me a times r squared plus r plus 1. And that does give me the a plus a times r plus a times r squared, right? It's going to be a times r squared plus ar plus a, and that's the same thing as that. We can just rearrange it if we want, right? A plus a times r plus a times r squared. So it works out. So let's go ahead and start the induction step. So induction step, we're going to suppose P of k is true. Thus, that means we're going to have a plus a times r plus a times r squared plus dot 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 plus a times r to the k is equal to, let's see, a times r to the k plus 1 minus 1 over r minus 1. Okay, so let's consider a plus a times r plus a times r squared plus dot 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 plus a times r to the k plus a times r to the k plus 1. So we'll consider the sum of these, right? From our induction step, we know this sum is equal to this formula. So this is equal to a times r to the k plus 1 minus 1 over r minus 1. And then we're going to add our a times r to the k plus 1, but we need a common denominator. So we're going to have r minus 1 times a times r to the k plus 1 over r minus 1. And what sticks out to me right off the bat is both of these terms have a common factor of a. So I'm going to factor out the a. I'm going to have r to the k plus 1 minus 1. And then, yeah, that's together, plus r minus 1 times r to the k plus 1 over r minus 1. And then this is going to be equal to a times r to the k plus 1 minus 1 plus r to the k plus 2, because r to the k plus 1 times r is r to the k plus 2, and then minus r to the k plus 1 over r over minus 1. And then this is equal to a, so we have r to the k plus 1 minus r to the k plus 1, so that's 0. So we're left with r to the k plus 2 minus 1 over r minus 1. And of course, we can rewrite this the way we want. R to the k plus 1 minus 1 over r minus 1. So we've shown that if we assume that the sum of these terms is equal to this formula, then the sum of the k plus 1 terms, right, is equal to the formula if we plug in k plus 1. So that is the principle of mathematical induction. So by PMI, for every n contained in the positive integers or natural numbers, right? We know this formula is true, right? We know a plus a times r plus a times r squared plus dot 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 plus a times r to the n is equal to a times r to the n plus 1 minus 1 over r minus 1. And that is our proof of the geometric series using the principle of mathematical induction.